Section 6.5, Solving Polynomial Equations. Part 1, Zero Product Property. The zero product property states that the product of two real numbers is zero if and only if one or both of the numbers in the product is zero. Symbolically, we have the following equivalence. If A times B equals zero, then A equals zero, or B equals zero. We can use the zero product property to solve polynomial equations of the form p of x equal to 0. So as long as the resulting non-zero side of the equation is factorable. Now remember, not everything is factorable. Example 1. Determine if the following equations can be solved using the zero product property. If they are not in the correct form, rearrange them to achieve the necessary form. So part A, 3x squared minus 2x plus 9 equals 0 is already in the correct form. So let's see if it's factorable. Well, there is no GCF, and the leading coefficient is 3. So I'm going to use the asterisk method. A times C is 27. B is negative 2. AX is 3x, and AX is 3x. Now we need two numbers that multiply to 27 and add up to negative 2. Now after you try this for a while, you're going to see you can't. Well, and that's because there are only two things that multiply to 27. You can have 1 times negative 27 or 3 times negative 9. And those add up to negative 26 and negative 6, respectively. Nothing is adding up to negative 2. So that means this is not factorable. So we can't use the zero product property, which I'm abbreviating ZPP. That does not mean this equation is not solvable. It just needs different methods to solve it. Part B. Well, already it doesn't look that good because it's not equal to 0. But we can make it equal to 0 quite easily. Let's subtract x squared, and add 5, and add 5 to both sides. 7 minus 5 minus 1 is x squared. Negative 9 plus 5 is negative 4, and we got 0. Then x plus 2 times x minus 2 is the factorization of x squared minus 4. So because I was able to get it equal to 0, and it was factorable, yes, this is solvable by the zero product property. Now we have 3x to the fourth minus 4x squared minus 4 is equal to 0. Now you might say, oh, we can't factor this because it's a fourth degree polynomial. It's not quadratic. But if you remember in class, we did talk about when this exponent is double that exponent, you can still factor it. So in this case, I'm still going to use the asterisk method. A times C will go up here, so we get negative 12. B will still go down here, so we get negative 4. But this time, instead of just AX, it's going to be AX squared, where you're using the smaller exponent. So then we get 3x squared and 3x squared. Now, what two numbers multiply to negative 12 and add up to negative 4? That's negative 6 and 2. Reduce, we get x squared over negative 2. So that means this factors as x squared minus 2. 3x squared plus 2 equal to 0. So we got it equal to 0. We were able to factor it. So yes, solvable by the zero product property. Once we have our equation in the correct form, namely polynomial equal to 0, we can factor the left-hand side of the equation using strategies from earlier this chapter. Once the non-zero side is factored, the zero product property tells us that one or more of our factors is equal to 0. For example, if x minus 3 times 2x plus 2 equals 0, then x minus 3 equals 0, or 2x plus 2 equals 0. And then we can solve these separately. First one gives us x equals 3. The second one gives us x equals negative 1. So the two solutions are 3 and negative 1. Example 2. Solve the following equations by factoring and using the zero product property. Part A. X squared plus 7x plus 12 equals 0. Since the leading coefficient is a 1, I'm going to guess and check. And we'll get x plus 3 and x plus 4. Now, by the zero product property, this means x plus 3 equals 0, or x plus 4 equals 0, which implies x equals negative 3, or x equals negative 4. Part B, 5x squared minus 10x equals 0. I'm going to factor out the GCF of 5x, get x minus 2. And then by the zero product property, that implies 5x equals 0, or x minus 2 equals 0. Divide by 5, we get x equals 0, or add 2, x equals 2. Part C, negative x squared plus 8x equals 12. Before I can factor this, I need to get it set equal to 0. So the first thing I'm going to do is add x squared and subtract 8x to both sides. Now you might ask, why didn't I just subtract the 12? Remember from the previous section, it is always nicer to have your first term be positive instead of negative. So now my leading coefficient is a 1, so I'm going to factor this by guess and check. And we get x minus 2 and x minus 6. So then by the zero product property, x minus 2 equals 0, or x minus 6 equals 0, which implies x equals 2, or x equals 6. Part D. 8x squared minus 3 equals 1 minus x squared. Again, it's not equal to 0, so I need to get it equal to 0 first. So I'm going to subtract 1 and add x squared to both sides. We get 9x squared minus 4 equals 0. This is a difference of squares, so I know this will factor as 3x minus 2 and 3x plus 2 equal to 0. Then by the zero product property, we get 3x minus 2 equals 0, or 3x plus 2 equals 0. Solving these equations separately, we get x equals 2/3, or x equals negative 2/3. Part E, 8x cubed equals 24x squared minus 18x. Again, I want 0 on one side, so I'm going to subtract 24x squared and add 18x to both sides. We get 8x cubed minus 24x squared plus 18x equal to 0. Then I can factor a 2x out, get 4x squared minus 12x plus 9 equal to 0. This is actually one of those perfect square trinomials, so I know it's going to factor into 2x minus 3 and 2x minus 3 equals 0. So then by the 0 product property, we get 2x equals 0, or 2x minus 3 equals 0, or 2x minus 3 equals 0. I'm not going to write 2x minus 3 equals 0 twice, though, but technically we would get 3 equations this time because we have 3 factors. And now, solving them separately, we get x equals 0, or x equals 3 halves. Example 3. Consider the function f of x equals x squared plus 2x minus 8. Find the real zeros of f of x. So remember, finding the zeros of a function is equivalent to taking the function equal to 0. So in this case, it's x squared plus 2x minus 8 equal to 0. The coefficient is equal to 1, so I'm going to factor by guess and check. We get x plus 6 and x minus 2, I believe. Sorry, not x plus 6, x plus 4 and x minus 2 equal to 0. So then by the 0 product property, x plus 4 equals 0, or x minus 2 equals 0. So we get the real zeros of this polynomial are x equals negative 4 or x equals 2. General guidelines for solving polynomial equations. Write the polynomial equation in standard form, solve for 0 and simplify, factor the non-zero side of the equation, set each factor with a variable equal to 0, solve each linear equation, and check your answers. And that's the end of section 6.5.